now we're here on chapter 3, talking about computer science and the foundation of knowledge model. So let's discuss our objectives. When we talk about computer science and foundation of knowledge model, we're going to describe the essential components of computer systems, including hardware and software. This will make me sweat because I still, to this day, am trying to figure it out. We're going to recognize the rapid evolution of computer systems and the benefit of keeping up to date with current trends and developments. We're going to analyze how computer systems function as tools for managing information and generating knowledge. We're going to define the concept of human-technology interfaces and articulate how computers can support collaboration, networking, and information exchange. And I know that, the whole computer movement, there's no computer movement. Computers are, and computer technology is just the way we process information anywhere, anything we do. And in healthcare, it's an inevitability, and it's very helpful, and it's the way we process healthcare nowadays. So as much as, we can cringe and say, I want to focus on information exchange that's not computer-based, that's sadly not really going to be the case. And not necessarily sadly, it's just all changing. Even the way we learn, look at us. We're sitting here online. I'm lecturing to you from another time and space. And so we have to really, truly understand the technology given to us so we can process that information properly. So the discipline of computer science is introduced to the focus on computers and the whole idea of hardware software that makes up the evolving systems. Computer science offers extremely valuable tools that, if used skillfully, can facilitate the acquisition and manipulation of data and information by nurses who can then synthesize these into evolving knowledge and wisdom base. Okay, great. So I used a bunch of words and they're scary. But this process facilitates our professional development and our ability to apply evidence-based practice within our nursing care. And if the results are disseminated and shared, we can also advance our profession. We can elevate our profession. So this chapter is going to look at the common computer hardware, followed by a brief overview of the operating, productivity, creativity, and communication software. So the hardware part of the computer, and then the software that we use within it. And it'll conclude with a glimpse of how computer systems help shape our knowledge. All right. So computers are tools for managing information and generating knowledge. Computer technology is ushered in what's been called the information age, an age when data, information, knowledge are both accessible and able to be manipulated by more people than ever, right? And not just the information that's presented, but the way how people process the information. How often are we putting up memes on Facebook about how we're so tired of our patients going on Google, right? But that is part of our informatics, how data is processed and then manipulated within people's brain based on other context. And so truly understanding the computer technology will help us have a basis for understanding of this information and how people use it, and also how to correct people's misinformation. So the computer is an electronic information processing machine. It serves as a tool to manipulate data and information and then present it. The easiest way to understand computers is to realize that they are just input-output systems. They accept data through a variety of devices. It processes the data through logical and arithmetic rendering. It stores data in memory, and it outputs data and information to a user. So the advent of the first electronic computer was in the mid-1940s, and it's evolved to become essential tools in every day of life. How many of you don't have any type of computer system in your house? I doubt it, right? I mean, even a smartphone is considered a computer system, even smart TVs. And so the complexity of computers has increased dramatically over the years, and they'll continue to do so. Computers change the world more than human endeavors, more than any other invention over the past 100 years, and comes to pervade nearly all endeavors. Yet, we're just at the beginning of the computing revolution. We're just at the beginning of our knowledge base. Major computer manufacturers and researchers such as Intel have identified the need to design computers to mask the growing complexity. So the sophistication of computers is evolving at amazing speed, yet also user-friendliness aspects have increased accordingly. This is really important because unless you're a super duper computer whiz, what good is all this technology if you don't know how to use it? So according to Intel's Corporation Technology Research Team, the goal is technology that just works. Conceal the complexity. Make it user-friendly. Now, if you want to get really good at it, that's great. But the point is finding the right technology that's generally user-friendly to everybody. Okay. So now let's talk about the acquisition of data and information, right? Hold on 1 second. Actually, I want to talk more about hardware. Just give me 1 second. Get my notes on it. So I'm just going to touch on each section of hardware. Okay. So, when we talk about the hardware of a computer, it refers to the actual physical body of the computer, okay? So there's the casing, there's desktops and laptops and palm computers. There's a central processing unit, which is really important. It's that part of the computer that actually executes, calculates, and processes the binary computer system. And when you hear people talking about binary code, that's how information is input into the computer. It's based on a number of systems of zeros and ones. And it's instigated by an operating system and other applications. So when people say, what's your operating system? And you say Microsoft or PC, and someone else says Mac, that is how the binary code is input. The CPU serves as a command center that directs the actions of all other computer components, and it manages both incoming and outgoing data. All right, so common CPUs are Pentium, K6, PowerPC, and Spark model. They use mechanical units that include registers, arithmetic logic units, kind of like algorithms, floating point unit, control circuitry, and cache memory. Together, these intercomponents from the computer central processor. And the cache memory is extremely quick memory that holds whatever data. That's why they say, clear your cache. And our CPU is measured in units of megahertz. All right, so the motherboard. This is called the central nervous system of the computer. It's a key foundational component because all other components are connected in some way, whether there's local sockets, USB ports, Ethernet cables, and the motherboard helps process that. Power supply, that's a critical component of the computer too because it provides the energy, right? We have batteries and we have wall units, and how you keep things charged is an important matter when it comes to that. The hard disk, this is a component named because of the rigid hard disk that resides in it. Not those old floppy disks. We're talking about mounted to a spindle that's spun by motor when it's used. These produce a magnetic field through the transducer that magnetizes the disk surface as voltage is applied to a disk, and it acts as a permanent data storage area that holds the gigabytes or even terabytes worth of data, information, documents, and programs in the computer. So backing up the hard disk is imperative. And the hard drive produces the voltage waveform that connects the head to write and read data. Wow, we are just learning so much about computer. So the random access memory is the RAM, and it's volatile memory because it is temporary storage. And there's a bunch of different parts of the memory. The read-only memory is essential permanent or semi-permanent non-volatile memory. I don't really know what that means, but it's a different type of memory. Then you have your BIOS, which is your basic input-output system, and it's a specific type of ROM used by the computer when it first boots up. Virtual memory is a special type of memory, and it's stored on the hard disk to provide temporary storage. Integrated drive electronic controllers are components to primary interface with the hard drive. Peripheral component interaction connection bus. So these are the plugins that we talk about. Okay, a few more things. So they'll talk about is a small computer system interface, the SCSI, and that the component provides the means to attach additional devices like DVDs, CDs, flash, USB, a modem, connection ports, graphic cards, video adapter cards, sound cards. A bit is the smallest chunk of data memory. A byte is a chunk of memory that consists of 8 bits. And then there's a megabyte, a gigabyte. 1 gigabyte equals 1,000 megabytes or terabytes, where 1 terabyte equals a trillion bytes or 1,000 gigabytes. So, I just got us through the really painful discussion of hardware. Now I'm going to talk about software, which makes a little more sense. So software comprises the application programs developed to facilitate various user functions such as writing, artwork, organization meetings, surfing the internet, right? So there are 4 categories of software: OS software, productivity software, creativity software, and communication software. So commercial software is like stuff that's in Apple, Microsoft, IBM, and Adobe. It dominates the market for software and has done so since the advent of the personal computer. Open source software. Open source movement began several years ago, but it's become more powerful. It's a growing number of open source markets. The open source movement began by developers who wish to offer their creation to others for the goods of community and encourage them to do the same. OS software is the most important software on any computer. It's the first program to load the computer startup, and it's fundamental for the operation system. So it's operating system software. It's how your computer is going to work. And it's described in 6 basic processes. It has memory management, device management, processor management, storage management, application interface, and user interface. And so Microsoft is probably the most commonly used operating system. Productivity software, such as Office suites, is the type of software most commonly used both in the workplace and on personal computers. And that's where you have like word processing, spreadsheets, data, web development, email programs. Creative software lets us draw, paint, render, and record. And communication software enables us to use dialogue, share, and network, like instant messaging or conferencing. And if you look at the different tables, it gets a little more in depth.